Hello. We're going to continue this section on deploying applications, and in particular on App Engine, standard, the standard environment, and we're going to go into more topics, so just more than just the basics. So the first thing we can look at is logs. So one of the things you can do is with App Engine is look at the logs of your apps, right? And the way you can do that is if you go to your project that has your App Engine running in it, and you go to logging, and we've seen logging before, but here they actually have a way of doing, kind of making this easier. So they actually have underneath here, you can actually kind of do pre-formed queries. So here's GAE application, and you can, this other, just so you know, these other services here that you see here. I was doing practice for this video, so that's why they're here. So I think the ones we looked at were like default, right? And then you can run the query. Oops, apparently I didn't select it. Well, there's right there, default. Then you run the query. Now, I don't think you're going to see anything in the last hour since I've not done much with it, but let me change this to, I don't know, 1 day, because I think I did this a day ago. Apply, right, and you can see all these logs. Now, the log that the log we know about is when we send console output saying example app listening on blah, right? So there's that. So there's, that's clearly that log, right? Okay, so I think that's all we're going to do with Log Explorer. So let me go back to dashboard. Okay, another topic that's at least mentioned in the title, right, is about scaling these apps. So remember, right? Let's look at App Engine again real quick. App Engine instances. Okay, so for now, you actually notice that there's no instances here, right? So what happens is App Engine is designed to scale your app, right? As you get more load, you'll get more instances. Now, so instances are basically as scaling happens, you'll basically grow more instances, is what I'm trying to say here. So now there's actually different mechanisms for doing scaling. So, and we'll go through a couple of them, like with examples. But first is called automatic scaling. So this is where it will scale based on the request rate. There's response latencies. Basically, you have a couple metrics that you can basically trigger the scaling up and scaling down. You can set thresholds for these values as well as set minimums and maximums for your number of instances. So that's the most flexible or most complicated version of scaling. Basic scaling is really more crude. It basically just says, okay, it'll scale up when something happens. You can set a maximum, but you can't do it doesn't do it based on rate. It's very simplistic. We'll look at that as an example. And then finally, manual scaling is kind of maybe the crudest of all, where you basically just say, create this many instances, and that's all it does. It doesn't scale up automatically or down. It just leaves it at the actual instances. Now, to make this a little bit more confusing, these different scaling types are actually only available on particular instance classes. So instance classes are basically, you can specify how much, by picking this instance class, we can show, pick how much CPU we're going to have, how much memory we're going to have. It's kind of like the machine types in the worlds of GCE. So certain instance classes only support automatic scaling, and certain instance classes only support the basic and manual scaling. So depending on what instance class you have different options on scaling. So that definitely makes it more confusing. So what we're going to look at here is what is our instances running right now. So let's look at that first. We didn't really get into specifying this, and the question is, well, what is it if we don't specify it? If you go under versions, and we scroll all the way to the right, there is a config view. And so if you remember on our default app, all we really did was gave it a runtime. So the only thing we actually specified was that. The rest of this was inferred as a default, right? So you can see it has we're definitely using the standard environment, right? So that gets inferred. Here you can see the instance class is F1. So there's a bunch of F1, Fs, like F2. So basically you can go up the F line of classes. There's also B. So we'll talk about that in a bit. So there's B1, B2, I think, right? So here we're using F1. And we won't talk about handlers, that's something else. But you can see here is the automatic scaling. So by default, we actually do get a F1 class, and that supports automatic scaling. And then pretty much everything is set to automatic. We'll come back and look at some of these parameters in a bit. But you can see that we are actually getting scaling. That's why when we actually hit this, you'll see all of a sudden we get a new instance. Okay, so yeah, just to illustrate that, I guess I could, oh, not what I wanted to do. If I go to versions, and if I just click on this version and redirect to the page, I actually get a result, even though there was no instances. And now if I come back to this screen, you'll see an instance running. And then this will basically scale down once, after a few minutes. I think it's like 10 minutes or so. This will scale back down, and then you'll have no instances again. Okay, so that is kind of a hint at, that even though we didn't specify anything, we actually get some scaling behavior out of the box, pretty much all automatic, right? Now, what we're going to do next is go through an exercise of creating something that does manual scaling. And here, as I suggested earlier, you actually have to use a different class of instance, in this case a B1, or up that chain, right, in order for you to get manual scaling to work. And it's true also for the basic scaling. Those only work on these B classes of instances. So what we're going to do here is we're going to look at an example of manual scaling. So let me go into here, go to my app. So this is, I've created 3 more examples here, first being 3, that uses manual scaling. We'll get to other ones shortly. So if we go into 3, what's different here? Basically all I did here was update the server to say 3, right, so I could distinguish it. I think I updated the package JSON just because I should. But not because I'm required to. And then the key, though, is the cat app.yaml. So this is really where the difference is. So before we just had maybe the runtime. We've seen the ability to change the service name. So here it says 3, but we're introducing 2 more things. So here we're saying we're using instance class of B1, right? And it's pretty much the same performance as the F1. It's just allows for basically manual scaling. And here you can see manual scaling instances 5. So when this runs, it should start up 5 instances and never scale up or scale down. So we can try this real quick. So if I do gcloud app deploy, it's going to say, do you want to create a new service? Right? And that's what it's doing. And here it is right here, 3, right? And I'm going to say yes. I'm going to pause the video because this takes up to about a minute or so. Okay, we're back. It deployed. So to see under the hood, the instances, if I go back to see versions, I think I have to hit refresh here to get it to recognize the new service. So there's 3, right? So I have this, and let me go to instances real quick. Yeah. So here you can see I actually have 5 instances, 1, 2, 3, 4, 5 running, even though I have never actually visited the page, right? Or I still have 5 instances. That's because I did manual scaling. Now what's interesting, under versions here, version 3, let me hit refresh on this. I'm curious. There seems to be a sort of a bug in there. They're suggesting that there's 0 instances, but there was actually 5 of them. So that's kind of broken, as far as I can tell. Okay, well, either way, that's an example of manual scaling. And of course, you could go to versions and look at the config here. You can definitely see The configuration here is manual scaling 5 of type B1. Okay, that's it for that. Let's go to the next topic. So that was the easiest. Before we get into, if you start reading the documentation on automatic scaling, there's a lot of energy spent around setting up these warm-up requests. So we'll go ahead and go through what's that about and do an example of that. So the scenario here is if you have an app getting ready, you've got it deployed, but maybe before it's set to serve, it's got to, gets that first request. That request then needs to spin up a new instance, start up your code, load all the dependencies in memory, and then serving the traffic. The problem is that first request, right, before your app is able to, when it first starts up, the problem is that latency of that first request may be rather high because it has to do a bunch of stuff before it actually responds. So what Google allows you to do is set up a warm-up request. So you set up a certain URL, right? And we'll go through the example that it'll hit first, let your code start up, load all those dependencies in memory, and then that's done before it actually gets added to the list of instances that can serve traffic. So it's just basically that way. From then on, you have the actual traffic gets a warmed up application and gets nice response rates. So a lot of the documentation around automatic scaling mentions you really need to set up a warm-up request. So I think the easiest way of doing it is to look at an example. So what you need to do is, I have another example, 4. And okay, so what we do here is you got to do a couple things. One is you need to be able to serve an address URL with a path of _AH/warmup. Now, this is true for all the languages. This is just a specific implementation for Node, right? So basically, I'm just saying, hey, if anything comes on AH warmup, I just return with response code 200 with hello warmup. So that's really all I did to change the code here. And then the only other change is under app YAML. You tell it that you actually have implemented a warmup. So here, just did inbound services warmup. So that way it knows whenever it tries to spin up these things, it will do a warm-up first, and then it will serve traffic from then on with a already pre-warmed instance. Okay, so the easy way to see this, we'll run it. I don't think we'll do much with it, but what I'm going to do is gcloud app deploy this one. And then I'll say yes, and I'm going to pause the video. Okay, so 4 is deployed. We can look at the versions here. Let's see, 3, 4 now. It's there, and of course we look at the config, which is over here. And we can of course see the warm-up, right? But realistically, it's hard to really detect like this is behaving differently. So I could have, just as a sidebar, I could have added an extra logging in the warm-up endpoint. So then I can look at the logs and see the warm-ups happening. But I didn't do that. So there's not much more to cover here. It's just a good practice to have a warm-ups endpoint available. Okay, so now that you have a warm-up, you can actually look at this documentation about automatic scaling. And I'm going to open it up real quick. You will see the reason I even mentioned warm-ups here is there's all this discussion about warning. In order for this feature to work properly, you need to have a warm-up request enabled, right? So that's why I did that exercise. So now I don't want to go through all the details here, but we already have automatic scaling work set up already, but everything is just set up to automatic. So this is where you can go in and specify the maximum instances, the minimum instances. There's these minimum and maximum idle instances, which I don't fully understand the distinction between those and actual ones, but they're different apparently. Then you can basically instead of just letting everything be automatic, you can go through and set, basically utilization targets for CPU, for throughput, okay, and such, right? So, and then you can also watch for latency, right? So you kind of grow your services or scale your services on a number of metrics here. And I don't want to go through all of them, but there's quite a bit of options here about how you might scale your. Typically, it might be CPU utilization or maybe latency that you would track on. Okay, I somehow zoomed here. What did I just do here? Okay, I'll put it back. Okay, next topic. Let's close this down. Okay, so again, the summary of that one is there are multiple ways of doing scaling. By default, you get automatic scaling with everything automated, right? If you don't do anything. You can do manual, you can do basic. Basic just basically just says, just basically allows you to set a maximum of instances, right? And then automatic, and then you can do manual too, where you actually specify the actual number of instances. And automatic, to use it properly or fully, you'll definitely want to read the docs, as there's quite a bit of options there about setting your scaling parameters. Okay, we'll move on to a different topic, traffic splitting. So, so far, when we deployed a new app, a version of the app, or the service to be precise, then you'll notice that the traffic allocation always goes 100% on the most recent. I don't think we have, wait, actually number 2, I think we have 2 versions, right? So when we deployed the newest version, 100% of the traffic went to the new version, right? So that's the default behavior. Now what we're going to do is we're going to do what's called traffic splitting, right? Where you can now tell it, hey, some of the traffic will, in fact, there's an option here called traffic splitting, where you can now allocate maybe half and half between the old version and the new version. So to do this, though, there's one thing we probably need to do first. So one of the things you got to be careful about with your browser is if you use the same URL, but behind the scenes there's different versions, you want to make sure that your browser is not caching the content. Otherwise, you're going to get you'll get confused. You'll not be getting the right version, right? So what we're going to do is we're going to turn off basically caching in our app so that your browser can't cache the result, and then we'll continue on with traffic splitting, right? So the first thing we want to look at is what do we need to do in our code to make your browser not cache it. So this is where we go to 5. So this is exactly the same as the previous version. In fact, I think the app YAML is right. I just left inbound. I left a warm up in here because it sounds like a good practice anyway, right? But here I've done nothing special in the YAML file. But here I did do a change in the server.js. So I actually added this section here, right? And you can see I've set it. Basically, this is Node's way of doing it. Right, just so you know. Well, first there's the general idea. The general idea that's not specific to Node is you add a cache control header to your response, right? And you provide a no store max age 0. This is kind of default way of saying don't cache me. Now the Node specific way of doing this is using this app use and this particular pattern. And so that means every request now gets this cache control header. Okay, so that's that. So that's that part of the business. Right, so I think we just go ahead and deploy this first. So I'm going to do gcloud app deploy. There's that. I hit yes. I'm going to pause the video until it's deployed. Okay, so now we've deployed our version 5, service 5, right? So now if we go to here, you can reload. I think I already did this earlier, but you can see 5's here now. And in particular, if I go to the 5 endpoint, right, you can see this is 5 dot, right? And if I go to inspect, just to make sure that I did things right, and I look under network, I reload this, I look at the response of and I can see response headers, I can see this cache controls here, right? So this is no longer caching. Okay. The next thing to do is deploy a different version of this app. So let's do that. So, right, okay, that's what we have to do. We have to come in here and do vi server.js. Let me just come in here and put a version 5 v2. Okay, and then I click that in gcloud cloud deploy app. Apparently this is not right. Gcloud app deploy. Oh my goodness. Yes. I'm going to pause the video again. Okay, we're back. So we've got, should have now 2 versions of 5. So let's see. 5. Yeah, there's the 2 versions there, right? So the next thing we can do now to do traffic splitting, right now 100% is going to the newest version. That's the default behavior. If I go under split traffic, let's see if I can get this right. Now there are 3 different ways of, and 2 of which they spend time talking about, 1 less. For splitting traffic, the default behavior is IP address. So the first thing it does is it will always, if you do IP addresses, if you have the same IP address, you always end up on the same version, right? Cookie actually puts a cookie on your machine, on your browser, or presumably your browser or whatever's making the request, and it will use the cookie to make sure that you always end up on the same, basically version, right? Now, why you might use cookie over IP address is the problem with IP addresses is that if you have different behaviors depending on which version of the app you're running, and users maybe are moving between a coffee shop or their home, they may get different experiences, right? And another problem with IP addresses is that sometimes they can be too sticky, where like a lot of traffic gets funneled through the same IP address, even from different browsers, right? So IP address is kind of crude. Cookie is a little more refined because it actually puts a cookie on your machine, and then that browser will always use that particular version. And so we'll do it that way, and so we can watch the behavior, right? Now we need to change the allocation. So I set up a new I marked the other version. There's only 2 versions right now, right? This is that one and that one. And then I'm going to mark it at 50%. So then we can go 50-50. So if I can hit save, now when I look at the screen updating, let's wait for this to update. Okay, so it says split. So if I look at this UI now, so you see it's 50-50 now between the 2 versions. So the way we can see this in action is if I go, so if I go back to service, go to 5, open this up. Okay, so here you'll see I'm running v2. Okay, now a couple things here to look at is if I hit inspect here, if I go under application, I believe, I go under cookies, which I did already. Here it is. Here's that cookie that just got added. This was not here until I checked that box, right? So now, because this cookie's here, I always, no matter what I do, I always get version 2. Now, to see if I can get the other version running, what I can do is I can open up a new incognito window. And if I get lucky, I think it will pick, at least this did for me the last time I did this exercise. So now I'm just using a different browser essentially. And let's see what version I get. 5 dot. Well, that's not good. Why is that not block? Oh, wait. Can't use cookies. Okay. I did not notice that. Okay. Unfortunately, I still got to V2. Now, I guess if I did this enough times, so now I think the problem is now I've got cookies again. So I am going to forever get V2. Oh, you know what I can do is I can delete my cookie. Let's see if I can do that. See if I can, I'm just trying to get the other version. Inspect, application, cookie, delete, hit reload. Of course, now I'm only getting V2. Delete. Well, that's not good. My earlier example I did, I got the V1, the original version of 5. Okay, I'm going to try one more time, but I'm going to give up here. Let me try it with this one. I'm curious to see. Inspect. Maybe by deleting the cookie, I'm not actually, I don't know. It should be. If I delete the cookie and hit reload, okay, I'm only getting the V2 for whatever reason, but trust me, when I did this earlier, I was able to get the, get the traffic splitting between the two. Yeah, that is interesting though. Okay, well I think that's it for this video. Yeah, that was an example of traffic splitting. Again, it is splitting, it's just I'm not able to simulate the splitting behavior. Okay, thank you.